Today we're going to be talking about finding the real zeros of polynomial functions. And so we're going to go back in time and we're going to do some dividing. The first way you learned to divide was when you had the fraction 4,711 divided by 23. You took the dividend, or excuse me, you took the denominator and made it the divisor of 23. And inside the divisor box, you put the dividend of 4711. And when you learn to divide, you should have learned that you look at your first digit and your first digit only. And if you do that, you would then say 2 goes into 4 how many times? And you should have said 2. So over here you take your entire divisor, 23, times 2, and you would multiply it out. 6, 4, and you would say, yes, 46. So you'd write your 4, 6 down, you put your 2 above the second digit because there were 2 digits here. Draw your line and put a minus sign in front. Now when you did this, did you just subtract the 4 minus 4? No, you also took the 7 minus 6. So this minus actually distributed to the 4 and to the 6. So 7 minus 6 would have been 1. 4 minus 4 would have been 0. Then you would bring down your next term. And again, you should say 2 goes into the first digit here, 1. How many times? And you would say 0. So you would put a 0 down. And it didn't fit in there, so you bring down your next number. Since I brought down another number, I now have to say it goes into 2 digits. So 2 goes into 11 5 times. So over here, you would then take 23 times 5, 15, here's my 115. And you would say, that's too big. I definitely know it's 4 times. Has to be just one less to fit. So then you do 23 times 4, 12, here's my 1, 9, 92 does fit. Right, your 92, draw your line, put your subtraction. And again, you'd have to subtract both the 9 and the 2. So 1 minus 2, it doesn't work. So you would borrow from here and put the 1. 11 minus 2 is 9, 10 minus 9 is 1. And then you would write R19. And as you became older, you learned that it meant 19 over 23. 204 and 19 23rds. And in mathematics means plus. So 204 plus 19 23rds. And the same process is going to be taken care of when you use polynomials. You are going to put your divisor on the outside and your dividend on the inside. You are going to look at just the first digit of each of those. So here's our polynomial. Y to the 4th plus 2y squared minus y plus 5 divided by y squared minus y plus 1. Now before we start that one, I want to ask you, if you had the problem 23 divided into 4,011, notice how this 0 is filled in for the hundreds place. Because if you do not fill in a 0 for that place, you have a whole different value of the number. If you just left that 0 out, you would have the number 411. And that is very different than 4,011. So it is very important that we account for every single place. The same goes with polynomials. But what determines our polynomial places is our degrees. The degree of this polynomial is 4. So I have to count down. Do I have a 4th degree? Yes. Do I have a 3rd? No, so I have to fill in a 0. 0 y cubes. Do I have a 2nd? Yes. Do I have a 1st? Yes. Do I have a 0? Yes. 4, 3, 2, 1, 0, all are there. So now I can write down my divisor, y squared minus y plus 1 should divide into y to the 4th plus 0y cubed plus 2y squared minus y plus 5. And I'm going to follow this process. First digit into first digit. Y squared divides into y to the 4th how many times? Y squared times. So over here you'll do y squared times y squared minus y plus 1. And when you distribute that out, you get y to the 4th minus y cubed plus y squared. Draw your line. And now I need to subtract. I needed to subtract both the 4 and the 6. Likewise here. Subtract the y squared. Subtract a negative y cubed. That turns into a positive. Subtract a y squared. Notice how all of these signs have to change if I'm subtracting every single one of them. And now I can go through. 0. 0 plus 1 is 1y cubed. 2y squared minus y squared is a positive 1y squared. Bring down my next term, minus y. And I repeat the process. Y squared goes into the first term, y cubed. Positive y times. So I come over here and take my y times y squared minus y plus 1, the entire divisor. And when I multiply that out, I get y cubed minus y squared plus y. Draw my line and subtract every single one of them. Y cubed minus y cubed, gone. 1y squared plus 1y squared, 2y squared. Negative y, negative 2y. Bring down my last term, plus 5. Actually, on my final process, y squared divides into 2y squared 2 times. So it is a positive 2. I have to take 2 times my divisor, y squared minus y plus 1. And when I multiply that out, I get 2y squared minus 2y plus 2. Draw my line, subtract every one of these. 0, 0, 3. Take my divisor, and it's and 3. So I put and is plus. 3 over my divisor, y squared minus y plus 1. That's long division. You have no choice but to use long division when you divide by a trinomial. If I am dividing by a binomial, I can use what's called synthetic division. So let's go through the rules for synthetic division. First of all, your divisor must be in the x minus h form. It is key that it is x minus h, because whatever is behind the minus sign goes in your divisor box. Then just like with long division, we had to account for every degree. We have to do this in synthetic division as well. But instead of writing the whole polynomial, we are going to just write the coefficients of every degree. As I said, we will be placing h in the divisor box. What is behind your minus sign? Then you will bring down the first term, multiply by your divisor, Add, multiply, add, multiply, add, multiply, add, till you're finished. Some people call this the mama method. Because you multiply, add until you're done. So let's look at an example. X cubed plus 2x squared minus 6x minus 5, all divided by x minus 2. This is a binomial in the x minus h form. So what is h? H is 2. So we place the 2 in our divisor box. Then we write down each coefficient. I have cube, square, linear, constant. All places taken care of. Coefficient of the cube is 1, so I write down 1. Coefficient of the square is 2. Coefficient of the linear is negative 6. Coefficient of the constant is negative 5. And then I draw my line. I bring down my first term. Now's when I begin my mama method. 2 times 1 is 2. Then here is where I add. 2 plus 2 is 4. Come back to my mama. 4 times 2 is 8. Then I add. Negative 6 and 8 is 2. I still have more multiplying. 2 times 2 is 4. Then I add. Negative 5 plus 4 is negative 1. And this is how it breaks down for your polynomials. The last thing was my remainder. Then I count backwards. This would be x to the 0 power, x to the 1 power, x squared. So my polynomial is 1x squared plus 4x plus 2 minus 1 over my divisor of x minus 2. Let's try some. First of all, x cubed minus x squared minus 2x plus 8. Let's first divide it by the binomial x minus 1. So what is my h? H is 1. So I put 1 in my divisor box. Then I check, is every position accounted for? Third, second, first, 0. So I can write down their coefficients. 1, negative 1, negative 2, 8. Draw my line, bring down my first term. Now I'm ready for mama. 1 times 1 is 1. Add 0. 0 times 1 is 0. Add negative 2. Negative 2 times 1 is negative 2. Add 6. Remainder, x to the 0, x to the 1, x squared. My polynomial is x squared plus 0x minus 2 plus 6 over my divisor of x minus 1. Let's take the same polynomial and divide it by b, x plus 2. What is my h here? This does not yet read the x minus form, so it would be x minus a negative 2. So my h is negative 2. So I put negative 2 in my divisor box. Same polynomial, so I have 1, negative 1, negative 2, and 8. Bring down my first term. 1 times negative 2 is negative 2. Add negative 3. Negative 3 times negative 2 is positive 6. Add 4. 4 times negative 2 is negative 8. Add 0. Remainder, x to the 0, x to the 1, x squared. My polynomial is x squared minus 3x plus 4 with no remainder. Okay. We have some remainder theorems. The first one says, if a polynomial is divided by x minus h, the remainder will be equivalent to f of k. So the two problems we just did were x cubed minus x squared minus 2x plus 8 divided by x minus 1. When I divided by x minus 1, 1 was my h. So I put that in my evaluation. If I stuck 1 in this polynomial, it would be equivalent to 6. And we can test that. 1 cubed minus 1 squared minus 2 times 1 plus 8. 1 minus 1 minus 2 plus 8 is, 2 plus 8 is 6. Synthetic division, whatever my remainder was, will be my answer when I evaluate at that value in the divisor box. We also had divided by x plus 2. And my h was negative 2. So f of negative 2 will be 0 because my remainder was 0. So I'm just going to go back there. My remainder was 6, so that meant f of 1, which was my h, would equal 6. Here my remainder was 0. My h was negative 2. So f of negative 2 would equal 0. I would not even have to plug numbers in to figure it out. I could just synthetic divide. So when you're asked to use the remainder theorem to prove if something's a factor, you will just stick in your h value and see what value it is. All right. Now we're going to talk about multiplicity. If a function has some of the same factors, we are going to say it has 0 multiplicity. Up to this point, if we've had 2 of the same factors, we said it was a double root. 3 of the same factors would be a triple root. 4 would be 4 of the same, 5 of the same. So instead, we're going to say it has 0 multiplicity. So if I have this factored form, if I solve this for 0, I would get x equals negative 2. Since that happened twice, I would say it has multiplicity of 2. Here, if I put this equal to 0, I would get x equals 1. Since that happened 3 times, I would say it has multiplicity of 3. So if you want the degree of this polynomial, you will always sum the multiplicities. So this polynomial would have a degree of 5, since 2 plus 3 is 5. So it is a 5th degree. Now let's look at what those functions look like graphically. If something has all odd multiplicity, it will cross the x-axis. Odd multiplicity will cross the x-axis. I choose zeros. This is a line, so my x is 1 power. It crosses the x-axis. This was a a cubic. It crossed over the x-axis. Do you recall when we drew a quintic? It also crossed over the x-axis, but became flatter in this area. When something has even multiplicity, it does not cross over the x-axis. It only touches it. It is tangent to the x-axis. Here is a parabola. It touches the x-axis. It has multiplicity of 2. Here is a fourth power. Remember how we said it would flatten out more? It still just touches the x-axis, tangent to it. It does not cross over. It has a multiplicity of 4. We've talked about this before. The higher the multiplicity, the more level the graph becomes. It flattens out. Now we're going to use this information. You also need to know that when something is in a complete factored form, here's my polynomial. ax something plus bx something plus cx plus dx plus da-da-da-da-da-da, down to your constant term. We learned a is the same no matter what. So a is our leading coefficient of the highest degree. Then we would have all of our factors after it. That's how you know you have complete factored form. So let's take a look. We have 2x cubed minus 4x squared minus 10x plus 12. I told you it has 3 zeros. Since it is cubed, we should know it should have 3 zeros. The degree should match the number of zeros. So let's take our 0, x equals 1. And we are supposed to write it in factored form. So we're supposed to go from the 0 back to the factor. So what factor would have given me the root of 1? I want to go back here where it said it equals 0. How am I going to go back to 0? I'd have to subtract 1. So I'd have to subtract 1. So my factor would have been x minus 1. If my root was negative 2, what would I have to do to go back to 0? Add 2. So my factor would have been x plus 2. If my root was 3, what would I have to do to go back to 0? Subtract 3. So my factor is x minus 3. And what was my leading coefficient? 2. So that becomes my a. And I now have my polynomial in factored form. But what if you aren't given all the roots? What can you do then? Well, the factor theorem says that if I do my synthetic division and I had it in the form x minus h, my remainder is 0. I know that I had a factor. So let's try that. My polynomial is 3x cubed plus 13x squared plus 2x minus 8. I am telling you that f of negative 4 is 0. So you know the remainder was 0 at negative 4. So negative 4 was a root. So what factor would have that been? I'd have to add 4 to go back to the 0. So I have a factor of x plus 4. How many factors should I have? 3, because my degree is 3. I have 1. So I know there are 2 more factors I need to find. So I'm going to synthetic divide my root into my polynomial so that I can get down to a square. And once I have a square, I should be able to factor it. Third degree, 3. Second degree, coefficient 13. First degree coefficient 2. It's constant coefficient, -8. Draw my line, bring down my first term. 3. -4 times 3, -12. Add 1. -4 times 1, -4. Add -2. -4 times -2, +8. Add 0. This was my remainder of 0, which is what it said. X to the 0, x to the 1, x squared. So my polynomial is 3x squared plus x minus 2. Can I factor that? Three x and x. Now how many choices for 2? 2 and 1. Inside 2x, outside 3x. Is their difference 1? To be positive 1, the 3 would be positive, the 2 would be negative. So I would also have the factors. 3x minus 2 and x plus 1. This is a factored form. To be completely factored, I would have to have this 3 be outside the parentheses. So if I factored that 3 out, I would have 3. 3 divide that is x. 3 divide there would be 2/3. And the other ones did not need that 3 to be factored out. So we can also use synthetic division to show factors. Because if the remainder is 0, I know I have a factor. And then I can keep synthetic dividing down till I get to a square. So let's try one more problem like this. But this time, the directions say, find the zeros. So they want you to find the factors, then solve for your zeros. So they said, one of my zeros of x cubed plus 6x squared plus 3x minus 10 is -5. So -5 goes in my divisor box. I also know if -5 was a 0, what factor did it come from? Add 5, it would be x plus 5. So I have a factor of x plus 5. Let's look, third power, second power, first power, 0 power. So 1, 6, 3, -10. Bring down my 1. -5 times 1, -5. Add 1. -5 times 1, -5. Add -2. -5 times -2, +10. Add 0. I should have had a remainder of 0. So this is my x to the 0, x to the 1, x squared. My polynomial is x squared plus x minus 2. Factor x and x. Factors of 2, 2 and 1. Difference should be +1, +2, -1. Unique coefficient is 1, so I'm good. Since they asked me to find the zeros, I'm going to solve each of these for 0. X equals -5. They gave me that one. X equals -2. X equals 1. 1, 2, 3 roots. Third degree, I should have 3 roots. How about What if I give you the graph? Can you give me the complete factored form? Well, let's first find our roots. Here I have a root, here I have a root, and here I have a root. My root is -5. What factor would that have come from? X plus 5. Here I have a root of 0. What factor would have that come from? X minus 0, which is just x. Here I have a root of 3. What factor would that have come from? Subtract 3, so x minus 3. Now, here the graph crossed over the x-axis. So that would be a single root, because it crossed over straight, not flat. Here, it just touched the x-axis. So you know it has to be a double root, an even root. Here, it crossed over and flattened out. So that would have to be an odd root. And since it flattened, it has to be more than 1. Now let's see if this degree would make sense. 3 plus 2 is 5, plus 1 is 6. This shows a 6th degree. By my end behaviors, as I go towards negative infinity, my y's go towards positive infinity. As I go towards positive infinity, my y's go towards positive infinity. When your end behaviors are the same, and they said my leading coefficient was a +1, would a 6th degree match that? Yes, it would. And back here is all the words I just said for an explanation of what occurred. I have 1, 2, 3 turning points, and this one is an inflection point, so that acts as 2 turning points. So 5 total turning points would mean a 6th degree as well. Since both end behaviors for x heading towards positive and negative infinity are the same towards positive infinity, also supports a 6th degree, and ending positively supports a positive leading coefficient. 0 is at -5 with multiplicity of 1 since it crosses over. At 0 with multiplicity of 2 because it is tangent. And at 3 with multiplicity of 3 because it crosses over and flattens out. Also supports a 6th degree. And I have just a couple more problems to show you. And tomorrow will be all work day. I'm getting my calculator up here too. Okay, let's see. All right, let's try one more. State the function in complete factored form. Hint, use the y-intercept to find a. Remember when we did this with quadratic? We did the same kind of thing. So let's first look at what we've got here. End behaviors are different. This end behavior heads towards positive infinity. This end behavior heads towards negative infinity. So I should have an odd degree. Here I have a 0 at -5. So what factor would that be? X plus 5. Here I have a 0 at 3. So what factor would that have come from? X minus 3. At -5, it crosses over straight, so its power would be 1. At 3, it just touches, so I need at least a square. And since my degree now comes to 3, that is odd. Two turning points would also match a third degree, so everything is in support. I don't know what A is, and I'm looking. I have a y-intercept of 0, -9. So I put 0 in the x spot and -9 in the y. -9 equals A times 5 times the -3 squared. A times 5 times 9. -9 equals 45A. Divide by 45. A equals -1/5. So I can replace this with a -1/5. And I have a completely factored form. All right, here's where we're going to start. It tells you your leading coefficient is 1/2. You have a 0 at -3. So that is x plus 3. You have a 0 at -2. You have a 0 at +2. And you have a 0 at 5. Three crosses over straight, power of 1. -2 touches, so it has to be even. 2 crosses over and flattens, so it has to be 3. 5 crosses over 1. 1 plus 3 is 4, 5, 6, 7th degree. Opposite end behaviors, starting negative to infinity, ending with positive infinity, leads to a positive leading coefficient. Matches. I have 1, 2, 3, inflection point 4, 5, 6 turning points, leads to 7th degree. Okay, let's take a look at the rational zero theorem. Every rational zero can be found by dividing the factors of P by the factors of Q. This is our polynomial. X cubed minus 4x squared minus 11x plus 30. P is always your constant, and Q is always your leading coefficient. So first we're going to start with the factors of P. The factors of 30. 1 and 30. Positive 1, positive 30, -1, -30. Positive -2, positive -15. Positive -3, positive -10. Positive -5, positive -6. Q is 1. It only has factors of 1. So my possible zeros would be P's over Q's. So if I take 1 over 1, I get 1. 30 over 1, I get 30. 2 over 1, I get 2. 15 over 1, I get 15. 3 over 1, I get 3. 10 over 1, I get 10. 5 over 1, I get 5. And 6 over 1, I get 6. Now there are a few ways that you can do it on your calculator. No matter what, press your y equals. Make sure your things in there are cleared out. Put your equation in your y equals. X cubed minus 4x squared minus 11x plus 30 And let's zoom 6 to look at the graph. Then if you hit your trace key, I have zeros, 1, 2, 3 of them, and I should have 3. So if I hit my trace key, it looks like I have a 0 at -3. So I can just type -3, enter. Was -3 actually a 0? Yes, it was, so x equals -3. It also looks like I have a 0 at 2. So now I just have to type 2 since my trace key was already hit. Hit enter. Was that also a 0? Yes, it was. And it looks like I have 1 at 3, 4, 5. So since trace had been hit, 5, enter. And yes, it was. I got all 3 zeros. But notice, this only runs from -10 to 10. So if I'd have had one of my zeros be at -15 or +15 or 30 or -30, I wouldn't have seen it here. So I also like to use this table method. So first go to table set. And I'm going to have it ask on my independent. That way, when I go to my table, I can ask the values. I could ask about +30. Did I get a 0 value? No. I could ask about -30. Did I get a 0 value? No. I could ask about -3. Did I get a 0? Yes. So in the table, by doing this ask thing, we could ask about every single one of them and see. From the graph, you can see from -10 to 10. You can choose which method you like best. So let's try one more. First of all, let's peek. -4. And we can just use 4 because we'll take care of it with our positive negative. Factors of 4, positive -1, positive -4, positive -2. What's cube? 15. Positive -1, positive -15, positive -3, positive -5. So my possibilities are P over Q. 1 over 1, 4 over 1, 2 over 1. 1 over 15, 4 over 15, 2 over 15. 1 over 3, 4 over 3, 2 over 3. 5 over 3, or excuse me, 1 over 5, P over Q, 1 over 5, plus or minus 4 over 5, plus or minus 2 over 5. This is also why I like it. Then I don't have to worry about the fractions. So you guys go through. Row 1, test 1, 4, 5, and 2. Row 2 and 3, test 1/15, 4/15, 2/15. Row 4 and 5, test 1/3, 4/3, 2/3. Row 6, test 1/5, 4/5, and -2/5. Positive -2/5. So I press my y equals 15x to the 4 minus 68x cubed minus 7x squared plus 24x minus 4. Yes. negative 2/3 worked. I should have 4 total roots. So I'm going to have to synthetic divide to get my other 2. So let's take 1/5 and synthetic divide it into 15, negative 68, negative 7, 24, and negative 4. Bring down my 15. 15 divide 5, 3. Add negative 65. Negative 65 divide 5, negative 13. Add negative 20. Negative 20 divide 5, negative 4. Add positive 20. 20 divide 5, 4, 0. I should get a remainder. So here becomes my new polynomial. This is called the compressed polynomial. We are going to take our second root into that compressed part, negative 2/3, just into this part. Bring down my 15. 1/3 of 15 is 5, times a negative 2 is negative 10. Add negative 75. 1/3 of 75 is 25, times 2 is 50. Add 30. 1/3 of 30, 10, times negative 2, negative 20. I got my 0 again. So this is remainder, x to the 0, x to the 1, x squared. So I have 15x squared minus 75x plus 30. There's a 15 in there. X squared minus 5x plus 2. Are there factors of 2 that add up to 5? No, so I'm going to have to use the quadratic formula. S equals the opposite of b, which would be 5, plus or minus the square root of 5 squared minus 4 times a times c all over 2 times a. 5 plus or minus the square root of 25 minus 8 over 2. 5 plus or minus square root 17 over 2. Is that 2 more roots? Now I got all 4 roots. Now you can spend time working on your assignment.